In this chapter, we will talk about one of the applications of NLP, which is text classification. So let's say I have some customer request or complaints in front of me. I am facing network issue. Kindly fix my network problem. I am not able to make phone calls. Fix this issue. I would like to subscribe for broadband service. I want to apply for broadband service in my office. Now, these are, let's say, different complaints or different requests. Now, often, let's say this particular telecom company, they are facing a problem that their complaints or requests are not resolved in the due time. Now, this is most probably because the complaints do not reach to the right department. And hence, we have decided that we will actually build an application that will send the complaint or which will forward the complaint to the right department. And for that, what we need to do is we need to train a machine learning algorithm with a set of all these complaints or requests. So each and every request or complaint is actually labeled. For example, the first two complaints are labeled as network related complaints, and the second two complaints are labeled as broadband related request. So, in future, whenever a complaint comes in, the computer algorithm will be able to predict whether this complaint is a network related problem or is it a request for broadband, and accordingly, it will be able to forward that or redirect that complaint to the right department. So, before I continue, let me talk about a few terminologies here. These individual inputs, these are known as documents. So this is a document. Document number one, document number two, document number three, and document number four. And a set of documents is known as a corpus. Okay, this set of document where we have four documents is known as a corpus. And obviously each document have an associated label, right? Each document have an associated label, correct? Now, what we will do is we'll take each and every document and we will perform the various pre processing steps that we have learned. For example, the first step will be to perform tokenization, that is, break down each and every document into small tokens. Okay, that is the tokenization step. After tokenization, once the tokenization is done, the second step would be to remove the stop words. Okay, to remove the stop words. So first of all, tokenization is done. Each and every document is now broken down into tokens. Now let's perform stop word removal. So let's say I am not, I would like to, I want to. All these are stop words. Okay, for, in my, for this, to, my. All these stop words have been removed. Okay, all these stop words have been removed. Now, second step would be to perform stemming and lemmatization if required, right? If you want to perform stemming and lemmatization, you can go ahead and you can do that, or else you can ignore it. Okay. Now, once the tokenization is done, stop words are removed. The next step that we need to go for is called the vectorization step. Okay, it's the vectorization step. All right. In vectorization, there are two types. One is the count vectorization, which is also known as a simple bag of words. Okay, and the other one is the TF IDF vectorization. Well, we will talk about the TF-IDF vectorization in the next video. Right now, let's focus on what is count vectorization. Okay, what is count vectorization or bag of words? So, first of all, what is vectorization? So, vectorization is a process of converting these documents into numbers. Okay, it's a process of converting these documents into numbers or vectors. Okay, so now we will take all the individual tokens which are left, okay, and we will not repeat them. Okay, only the unique, we will pick up the unique tokens and we will not repeat them. So facing network issue, kindly fix network problem. Network appears second time, so we will not write it again. So facing network issue, kindly fix problem. Let's write it down. Facing network issue, kindly fix problem. So as you can see that I'm not writing the network again because it has already appeared. Okay. Then we will continue this. In the next we have uh, able make phone calls. Fix already has been there and issue. So able make, I think able is a stop word. Even if it is not a stop word, let us consider that it is a stop word as well right now. Okay. So make phone calls. Fix is already covered. Issue. Okay. So make phone calls and issue. All right. I will see what are the other remaining tokens. So subscribe broadband service. Okay. Subscribe broadband service. Service. I don't want that to go to the next line. Is it coming to the next line? Okay, no problem. I'll write a new text here. Service, and we'll go to the last document. Apply. Broadband already is covered. Service is already covered, and office. So apply and office. That's the other two. Set of tokens. So these are the set of unique tokens. Okay, these are the set of unique tokens. All right. Now, for each and every document, these tokens will be considered as features. Okay, for every document, these tokens will be considered as different features. Okay, so let's see what all tokens appear in the first document and how many times. So facing appears once, network appears twice, issue appears once, kindly appears once, fix appears once, and problem appears once. So for the first document, we have facing, network appears twice, issue appears once, kindly appears once, fix appears once, and problem appears once. The rest everything appears, rest of everything do not appear. So all that will be 0. Okay. Now let's look into the second document. For the second document, we have make phone calls, fix issue. So make phone calls, fix issue, and rest everything do not appear. So that will be 0. Okay. So guys, that is count vectorizer. This is an example of count vectorization. Each and every document is represented. Okay. Each and every token in the document is represented by its frequency. So for example, in the first document, facing issue, kindly fix problem, these tokens appears once. So that's why they are replaced by 1. Network appears twice. So that is 2. and the other tokens do not appear, so all that are 0. Similarly, this is the second document. Similarly, let's quickly make the third and the fourth document as well. So we have subscribe broadband service. So subscribe broadband service, and rest everything is just 0. Okay, rest everything is just 0. And if you take the last one, broadband service office. So broadband, so one second, broadband service office, and rest everything is just simply 0. Okay, rest everything is just simply 0. Okay, perfect. I think I'll just write down this one, straight line. Yeah, perfect, perfect. So what you see in front of you right now is the documents getting converted into the form of numbers, or you can say vectors. Each and every document, if this is the if these are the different features, so in the feature space, okay, in the feature space, these numbers represent each and every document. So the first vector or the first row, the first vector or the first row represent the first document. Second vector or the second row represent the second document, and third and fourth. Now, for both the labels that we have, that is, we have the network label and the broadband label. So you can label encode that as well, right? You can encode that as well. So let's say all the network related problems will be marked as 1, and all the broadband related requests will be marked as 0. So this is nothing but your target, your label. Okay. So the data is finally converted in such a form that you can use this data for machine learning purpose. You can train an algorithm using this data, and in future, whenever a new complaint arises, that complaint will be first converted using count vectorizer, and after getting converted using count vectorizer, we will pass that data to the machine learning. Machine learning will predict whether it is a complaint for network, or is it a request for the broadband. This is an example of count vectorizer. We will see example of TF-IDF vectorizer in the next video.